Welcome to the Explainer. So how exactly does a search engine sift through billions and billions of pages to find that one piece of information you actually need? Well, the answer lies in a pretty brilliant algorithm that basically turned the chaotic early web into a library we can all use.
All right, so first up, let's talk about the problem that early search engines were trying to solve. Just try to imagine a global library with billions of books, but absolutely no card catalog. That, right there, was the early web.
And this was the central challenge. In a digital universe that was just exploding with new content, how do you figure out what's authoritative and trustworthy versus what's just, noise?
The first attempt at this was pretty basic. It just counted how many times a keyword showed up on a page. But as you can probably guess, this was incredibly easy to game. Spammers would just stuff their pages with invisible keywords to trick the system, pushing all this junk to the top of the results. Something much, much smarter was needed.
All of this chaos eventually led to a revolutionary idea. It was one of those things that's actually simple in concept, but incredibly powerful in practice. So, what was this big idea that completely changed the search game?
The answer was to stop seeing the web as a collection of documents and start seeing it as one giant graph. Now, for anyone who's familiar with relational databases, this is going to sound really intuitive. Just think of each web page as a node, kind of like a table, and every single hyperlink as an edge. That's the relationship connecting them.
And here's the crucial insight. PageRank treated hyperlinks like they were votes of confidence. It's a lot like in academia, right? When a paper gets a lot of citations in respected journals, that signals its importance. In the same way, a link from one page to another was seen as an endorsement. It wasn't just about what a page said about itself, it was about what other pages said about it.
So, the way this process works is iterative. It starts out by giving every single page on the web an equal score. Then, in cycles, pages pass their scores along through their links. This just keeps repeating, letting all that rank score flow through the network until everything stabilizes. And when it does, it reveals this really clear hierarchy of importance.
But, no system is perfect. This really elegant ranking model, it had a few critical flaws that could actually cause the whole process to just grind to a halt. So the algorithm had two main vulnerabilities. First, you had dead ends. These are pages that get links, and therefore get rank, but they have no links going out. They basically become what's known as a rank sink, hoarding all that authority and draining it from the rest of the web graph. And the second problem was spider traps. These are groups of pages that just link to each other, creating a closed loop that endlessly passes rank back and forth, which artificially inflates their own importance.
I mean, these flaws could basically break the entire system. So how did its designers figure out how to get the algorithm unstood?
The solution they came up with was, well, it was really clever. It's called teleporting. It's designed to model a typical web surfer, like you or me. Most of the time, we follow links. But every now and then, we get bored and just jump to a completely random page. That teleport is what allows rank to escape from those dead ends and spider traps, and it keeps authority flowing freely across the entire web.
What's really fascinating is how this core idea, ranking nodes in a graph, is just incredibly versatile. It has applications far, far beyond just web search.
Oh, for sure. Take fraud detection, for instance. In this case, the nodes can be people, or bank accounts, or companies, and the edges are the transactions between them. A PageRank-style algorithm is brilliant at spotting suspicious clusters, these little groups that look a lot like financial spider traps. It helps reveal these hidden connections between actors that might seem totally unrelated at first glance.
Or think about e-commerce. This is something you've definitely seen. It's the engine behind that customers who bought this also bought feature. Here, the products are the nodes, and your purchases are the votes. The algorithm goes out and finds products with high authority based on what other customers who are kind of like you are buying.
But of course, the web never stops evolving. And just ranking pages based on links, well, that's not enough anymore. The challenges today are different. So why did we need to move beyond PageRank? Well, the answer lies in a really fundamental shift from simply looking at keywords to understanding meaning. Early search just matched the exact words you typed. But modern search, it uses semantic understanding to figure out your intent. It's not about matching text anymore, it's about understanding concepts.
And this evolution, it happened over time.
While PageRank was definitely king back in 1998, the real turning point was probably the Hummingbird update in 2013. That's when search engines really started to understand natural, conversational questions and the actual meaning behind them.
And that brings us to today. Modern search engines use these incredibly sophisticated AI algorithms to figure out the meaning on both sides of the equation. They analyze what you mean by your query, and they analyze what the content on a web page actually means, all to deliver a result that's way more accurate and relevant.
So this leaves us with a really fascinating question for the future. As AI gets powerful enough to just answer our questions directly, what happens to the whole idea of searching for something? That brings us to the end of this explainer. If you want more complex topics broken down just like this, be sure to like, share, and subscribe.